Greetings, I'm Dev the developer.
And I'm Glitch.
We have a payroll system with an employee hierarchy and it's in good shape. But today we're going to hit a wall that inheritance cannot climb over. The fix is something called an interface, and once you see what it does, abstract classes and interfaces will each have their own clear job. Let me set up the problem. You've been following along with our employee class, so you know that we have hourly employee, salaried employee, and manager. All of them extend employee, and employee forces each one to implement calculate pay. That's been working great.
Yeah, and we also have getTitle on employee that each type can override if they want.
Right. So here's the new requirement. The payroll system needs to produce a report for every employee. A human readable string, who the person is, what they earned, that kind of thing. How do you add that?
Easy, put GetReport on employee, make it abstract, same as calculate pay. Each type has to implement it.
That covers the employees. Now, separately, there's a BankAccount class. Same reporting system, same requirement. BankAccount also needs to be able to produce a report.
So BankAccount could also have a GetReport method. Just write it there too.
Okay. Now the reporting system has to call GetReport on both of these. How does it do that?
It calls GetReport on whatever it has.
But BankAccount is not an employee. The reporting system can't put both an employee and a bank account in the same variable or pass them to the same method. They have no shared type. The compiler doesn't know that they're related because by type, they're not.
But they both have GetReport. Doesn't that count for something?
Not without something telling the type system they share that method. Two classes both having the method name GetReport is a coincidence. The compiler doesn't connect them based on matching names.
So BankAccount could extend employee, then they'd share the type.
Is a bank account an employee?
No, that doesn't make any sense. You can't just inherit from something to get a method. That's lying to the type system.
You'd also be importing all of employees' behavior. Calculate pay, get title, all of it. A bank account doesn't have a pay period.
Yeah, okay, that's genuinely bad. So what do?
You separate the question of what something is from the question of what something can do. Employee answers what it is. The tool we need today answers what it can do. That tool is an interface.
What's an interface?
Think about a job posting. The posting says, must hold a commercial's driver's license, must speak 2 languages, must be able to produce a quarterly report. The posting says nothing about who you are or where you come from. 2 completely different people can satisfy the same posting. The posting only cares about compatibility. An interface is a job posting for code.
So it's a list of methods a class has to have.
A list of method signatures that a class promises to provide. No code inside, no fields, no implementation at all, just the signatures. It's a contract. If a class signs a contract, it must provide every method listed. The compiler enforces it.
Let me write one. That's it, 4 lines.
That's the whole interface. 1 method signature, no body, just a semicolon. No public keyword before the method.
Wait, why no public?
Interface members are implicitly public. Writing it would be redundant, and in a traditional C# syntax, it's actually a compiler error. The interface says what must exist. It doesn't need to specify visibility because there's only one option: public.
And the name IReportable, capital I at the front.
That's one of the strongest naming conventions in C#. When you see a type name with a capital I prefix, you know immediately it is an interface. The .NET Standard Library is full of them. IComparable, IDisposable, IEnumerable. You'll see this pattern constantly.
Okay, now I want to make HourlyEmployee implement this. Let me update the class. Okay, so the base class is employee. I just add the interface after it. There's a comma between employee and IReportable. Does that mean I'm inheriting from both?
What do you think?
Well, employee is a class and IReportable is an interface. They're different things, so the comma is just a separator, like the class extends employee and also signs the IReportable contract.
Exactly. The base class comes first, then after the comma, you list the interfaces you're implementing. They're different kinds of relationships and they sit differently in that list.
Got it, now I have to actually write GetReports.
And notice inside the class method is public. The interface said nothing about the access modifier because the interface doesn't implement anything. When you write the actual method body in the class, you declare it public yourself.
So the interface is the requirement and the class is the fulfillment. They're separate documents, sort of.
That's a good way to think about it. Now, here's what I want to try. Comment out the GetReport method. Don't delete it, just take it out temporarily.
Okay. So now HourlyEmployee says it implements IReportable, but there's no GetReport.
What does the editor show?
There's a red underline right on the class name. The error message says HourlyEmployee does not implement interface member IReportable.getReport.
The compiler caught it before the program ever ran.
Oh, so the interface doesn't just document the requirement, it enforces it. The code literally won't build if you sign the contract and skip a method.
That's the point. If you're building a system that depends on every reportable type being able to produce a report, you never have to audit your code and hope that someone remembered. The compiler does it for you.
Okay, restored, now I want to do BankAccount, because that's actually what started this whole conversation.
Keep it simple. This class only needs enough to show the point.
No base class at all, just the interface. And GetReport looks completely different from HourlyEmployee's version, but they both fulfill the same contract.
And what relationship does BankAccount have to employee?
None, zero, they don't share any ancestor. They have nothing in common except that they both implement IReportable.
And that's the thing inheritance genuinely cannot do. You cannot drag two unrelated class hierarchies under one abstract base class just because they share a compatibility. But you can make them both sign the same interface. And then the thing that needs reports doesn't have to know or care which one it's talking to.
Wait, so can a class implement more than one interface? Like what if commission employee needs to be both IReportable and something else?
A class can implement as many interfaces as it needs. List them all after the base class separated by commas.
Let me make a second interface and try it. Employee first, then IReportable, then iSummary, all comma separated.
And the rule holds. Base class always comes first. Interfaces follow.
Now I have to fulfill both. Let me add the method bodies. 2 interfaces, 2 methods, 1 class, and C# is fine with it.
And there's no limit to how many you can add. 1 base class, unlimited interfaces, those 2 mechanisms are designed to work together.
Wait, so the 1 base class rule doesn't apply to interfaces at all?
Correct. Single inheritance applies to classes. Interfaces are separate. You can implement as many as your class needs.
Okay, now we have HourlyEmployee and BankAccount both implementing IReportable. How do I actually use that? Like, how does the reporting system call GetReport on both of them without knowing which one it has?
Good question. Let's go to Program.cs and look at that.
Okay, so first let me create some objects to work with. Now I want to call GetReport on both. I could just call it directly on each one, but you said something about the reporting system not knowing which type it has, so let me think about that. I could put both of them in a variable, but the type of the variable would have to be... Actually, wait, I could do this. Alice is an HourlyEmployee which extends employee, so I can store her in an employee variable, and then...
Does that compile?
Let me check the employee base class. Does it have GetReport? It does not. Calculate pay is there. Get title is there. GetReport is not on employee, so calling it through an employee variable won't work. The compiler only sees what the variable type exposes.
Right. And even if you added GetReport to employee, that doesn't help with BankAccount because BankAccount doesn't extend employee.
Okay, so employee doesn't work and BankAccount doesn't have a base class I can use. The only thing they have in common is IReportable.
So what variable type would work for both?
Oh, IReportable. I can use IReportable as the variable type. Both assignments are valid because both types implement IReportable. And GetReport is on the interface, so I can call it through R no matter what R actually holds.
When you call GetReport through R the first time, which implementation runs?
Hourly employees, because that's what Alice actually is. The variable type is IReportable, but the actual object is still an hourly employee.
And the second call?
Bank accounts, because R now holds ACT, same variable type, different object, different output.
That's the key thing. The interface type tells the compiler what you're allowed to call. The actual object underneath determines what runs.
So declaring the variable as IReportable narrows what I can see through it, but it doesn't change the object. The object is still fully itself underneath.
Right. Through an IReportable variable, you can only call what IReportable exposes. Calculate pay, hourly rate, all of that is still there on Alice, you just can't get to it through R. You've narrowed your view.
And you can also do the cast explicitly, right? Like, if I already have an employee variable and I know it implements IReportable, I could cast it.
Show me.
Okay, I already went ahead and added IReportable to salaried employee and wrote its GetReport the same way we did for hourly employee. So emp here is actually an IReportable, even though the variable type says employee. The cast on the second line in parentheses IReportable, that says treat emp as an IReportable. Since salaried employee implements the interface, the cast works, and then I can call GetReport through as reportable.
And salaried employees GetReport runs, not a generic version, the real one.
That's actually a really satisfying pattern. The reporting system just needs a method that accepts an IReportable. You hand it anything that signs the contract, it calls GetReport. Done. It never needs to know if it's an employee or an account or whatever else.
Which is exactly where we started. The reporting system that couldn't handle employee and bank account the same way. Now it can, and it didn't require either class to change its identity or inherit from something unrelated.
Okay, so now I want to think about this versus abstract classes, because they both feel like you must implement this. What's the actual difference?
What can an abstract class contain that an interface cannot?
Code, actual method bodies, fields. Employee has the name, property, and the protected constructor. That's real state. An interface has none of that. No fields, no bodies, no constructors.
So what does that tell you about when to use which?
If the types you're grouping share actual data or behavior, abstract class. If they just need to share a capability and you're not making any claims about what they are, interface.
That's the test. Is a with shared state, abstract class. Can do, compatibility that might cut across unrelated types, interface. Hourly employee is an employee. That's an is a. Hourly employee can produce a report, so can bank account. That's can do. Different question, different tool.
And I can use both at once. Hourly employee is an employee and it can produce a report.
The two mechanisms are designed to be used together. Inheritance handles the family tree. Interfaces handle the compatibility contracts. Most real systems use both.
So if you think about it, an interface is basically a protocol. You define the surface any compliant party must expose. Then anything that needs to interoperate just checks for the protocol, calls through it, and the actual responding entity could be from any system at all, any origin, any hierarchy. You define the protocol once and then any entity, regardless of class ancestry, just signs on. You could have a single interface that every device in a network has to implement. Every node, every connected system. Phase 1 would just be getting them all to sign. I mean, you could model a large enterprise software system that way, for like logging across microservices.
I'm going to pretend I didn't hear most of that. And that's the thing that makes interfaces different from everything else we've covered. The contract crosses hierarchy lines entirely. Hourly employee and bank account have nothing in common by type, but the compiler treats them the same through IReportable. No shared ancestor needed.
And casting an object to an interface type narrows what you can call through that variable, but the object is still itself. The actual implementation that runs is still the concrete class's version.
That pattern, one variable type holding different objects and producing different results, has a name. We'll get into it fully in the next video, but you've already seen it working. You swapped 3 objects in the same IReportable variable and got 3 completely different reports.
Wait, so everything we just did, that's the setup for the next topic.
Interfaces are what makes the next topic possible. Once you have the contract, you have a shared surface to work through.
That's actually kind of exciting. It feels like the interface was the missing piece.
It usually is. Once you see what a contract gives you, the next question is, what can I do with it? And the answer turns out to be quite a lot. But first, you need the contract. You've got it now. You have an employee hierarchy, a bank account that shows nothing with it, 2 interfaces, and a program that uses all of them. Go make your own version, wire it up, see the compile error when you skip a method. That moment is worth more than any explanation. Don't just watch it, do it.